All right. We went over multiplying matrices the other day. I want to review that one more time and talk specifically about what matrices you can and cannot multiply. The important thing to look at when asking this question is what is the size of each matrix? So, for instance, can I multiply matrix A times matrix B as listed here? Well, matrix A is a 1 by 2, one row, two columns. Matrix B is a 2 by 3. It has two rows of three columns. Can we multiply these? And the answer is yes. I can take this row and multiply it by this column, and then I could take that row and multiply it by the second column and that row by the third column. There are two numbers in this row, there are two numbers in that column, so it's a match. So what you do is you look at these inside numbers here. If those match, then I can do it. When I actually multiply it out, I'm going to get three rows, I'm going to get three columns of answers because I'm going to multiply this row times that column, this row times that column, and this row times that column. So in the end, what I'm going to end up with is a 1 by 3. So you can look at the outside numbers, and it will tell you the size that you'll end up with. So this is going to be a 1 by 3 when we multiply it out. So let's go ahead and do it. I'm going to write it out completely here. One row of three columns. So I'm going to go 5 times 1, and then 1 times 4, 5 times 2, and 1 times 5, and then 5 times 3, and 1 times 6. Remember, after you get done multiplying, you add the results. So in the end, what I'm going to get for A times B is 5 plus 4 is 9, 10 plus 5 is 15, and 15 plus 6 is 21. And that is the answer. So let's try another one. Can we multiply A times C? A is a 1 by 2. C is a 3 by 2. Do these match? They do not. So no, we cannot do this. No answer. I take these two numbers and I turn them sideways to match this column here. And two numbers versus three numbers, it doesn't match, so we can't do that. Another one, let's look at a different one. Can I do B times C? B, again, is a 2 by 3. C is a 3 by 2. It's got three rows of two columns. So this one is a match. And again, to get the size of your answer, you're going to look at the outside numbers. It's going to end up being a 2 by 2. So what is that going to look like? Well, I'm going to multiply these two rows times those two columns, and that's why I'm going to end up with a 2 by 2. So we go 1, 2, 3 times 3, 0, 1. So 1 times 3, 2 times 0, and 3 times 1. And that gets us the upper left spot in this 2 by 2 answer matrix. To get the upper right spot, we multiply the upper row times the right column. 1 times 2, 2 times 4, and 3 times 5. Bottom left, 4 times 3, 5 times 0, and 6 times 1. Notice we're in the bottom row this time because we're in the bottom row of our answer matrix. And then finally, bottom row times right column, 4 times 2, 5 times 4, and 6 times 5. So in the end for that one, we end up with 9 and 25 and 18 and 58. Like that. So just as another example of something we can do, I'm not going to multiply it out. Can we do A times D? A is a 1 by 2. D is a 2 by 2. So the answer is yes. We're going to end up with one row of two answers. Now, what is the point of all this? Why? Why are we multiplying like this? What is this? Well, think about how we were representing shapes the other day. Let's say I have a shape that is a triangle. So remember, our x's are going to go on top, our y's are going to go on bottom. I'll just do the 1, 2, 3, 4, 5, 6. This means I have three vertices. 1, 4 is the first vertex, 2, 5, and 3, 6. Now imagine taking that times this matrix. This is a 2 by 2 matrix. This is a 2 by 3 matrix. It's a match, so we can do it, and what we're going to end up with is a 2 by 3 matrix. So in the end, the size of our answer matrix is going to be the same size as our triangle matrix. It's going to be 2 rows of 3 columns. Now really take a look at what we end up with here though. When I multiply this row times this column, I'm going to go 1 times 1 and then 0 times 4. The 0 here is very purposeful. It makes it so that the 4 doesn't really factor into the answer. So I'm just going to go 1 times 1 is 1, and that's my answer. Then I move to the next column, 2, 5. 1 times 2 is 2. 0 times 5, nothing, so just 2. 1 times 3 is 3. 0 times 6 is 0, so just 3. So our top row did not change. So you might think, well, what's the point if we're not going to change anything? Well, look at the bottom row. This time in the bottom row, we're going to go 0 times 1 and negative 1 times 4, and we end up getting negative 4. 0 times 2 and negative 1 times 5, and 0 times 3 and negative 1 times 6. So these are our x's, these are our y's. Think about what's happened to our shape. All the y's that were positive have now flipped and become negative. What does that do to our shape? If we graphed this image, what kind of transformation would that be? If we took all our y's and instead of making them positive, we flipped them to be negative. What kind of transformation would that be? That's what our next section is going to be all about.